أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Adewale I. Mikhail, the mathematics teacher for Senior Secondary School 2, CTY Model College, Ibadan. Inshallah, we are going to continue with our discussion on latitude and longitude. But before we proceed, let's quickly have a review of what we discussed in the last class. We discussed the concept of latitude and longitude. We said lines of latitude run from the east to the west of the globe, while lines of longitude run from the north to the south of the globe. We also discussed the location of positions on the globe. We said positions could be located on the globe by using the given angle of latitude and that of longitude. Where the two intersect, that is, where the line of latitude intersects with the line of longitude, give the location of a particular place. We also discussed the relationship between the small circle and the great circle. We said that all parallels of latitude are small circle except the equator, which is a great circle, while all lines of longitude, which are called meridians, are great circle, and that the small circle is related to the great circle by r equals big R cos alpha, where big R is the radius of the earth and alpha is the angle of the given latitude. We also discussed the angular difference between 2 points on the globe. We said that the angular difference between 2 points on the globe depends on the position of the 2 points. If the 2 points are in the same hemisphere, that is in the same pole, maybe north and north or south and south, then we are going to subtract the two angles. If they are in different poles, then we add the two angles together. Remember, in our elementary science we say that like poles repel while unlike poles attract. We can also use this fact to be remembering the addition or subtraction of a thing under this discussion. Today we are going to have a discussion on how to calculate the distance between 2 points on the surface of the earth. Example 1. An aircraft moves from a location P, 28 degree north, 15 degree east, to another location T, 28 degree north, 25 degree west, and then to a location K, 32 degree south, 25 degree west. Calculate 1. The radius of latitude 28 degree north. 2. The distance between P to T. 3. The distance from T to K. And 4. The average speed of the aircraft if the journey takes 20 hours. Given radius of the earth equals 6,400 km, pi equals 3.142. Solution. The first thing is to sketch a diagram that shows the positions of point P, T, and K using their latitudes and longitude. Recall, where the line of latitude intersects with the line of longitude gives the position of the place. For example, location of point P on the globe will be where the latitude 20 degree north intersects with the longitude 15 degree east. As it could be seen on the diagram, point P is in the eastern part of the longitude, while it is in the northern part of the latitude. Then we have our point T and also point K located on the globe. Now, the first question says we find the radius of the latitude 28 degree north. Remember, this latitude is a small circle, and hence we are going to use the relationship between the small circle and the great circle, which is given as our radius equals big R cos alpha, which gives us 6,400 times cos 28 degree. and that gives 5,650.56 kilometer. Note, this radius is less than the radius of the earth because it must be smaller than the radius of the earth, being a small circle. 2. We are going to find the distance between point P and point T. In this case also, we need to get our angular difference between P and T. The angular difference between P and T will give us 15 degree plus 25 degree. Why? Because point T and point P are on the same latitude. The angular difference will be the addition or subtraction of their longitudes. In this case, since they are in different poles, we are going to add their angles together. So we have 15 degree plus 25 degree, and that gives us 40 degree. Having got the angular difference, we are going to calculate the distance between T and P. We take this as an arc of a circle because point P and point T are like arcs on the circumference of a circle. Hence, we use the formula distance PT equals theta over 360 times 2 pi r, where theta is the angular difference between P and T, r, which is the capital R, is the radius of the earth, and cos alpha is the cosine of the angle of their common latitude. Substitute, we have 40 over 360 times 2 times 3.142 times 5,650.56, and that gives 3,946.35 kilometer. That is the distance between P and T. The third question says we should find the distance between T and K. In this case, we also need to find the angular difference between T and K, and that gives us the addition of their angle of latitudes. Why? Because they are on the same longitude. Hence, we are going to have angular difference between T and K to be equal to 28 degree plus 32 degree, and that gives 60 degree. So distance TK is equal to 60 over 360 times 2 pi r. In this case, the radius is going to be the radius of the earth because we are on a great circle, which is a line of longitude. Hence, we have 60 over 360 times 2 times 3.142 times 6,400, and that gives us 6,702.93 kilometer. That is the distance between T and K. The last question now asks us that we should find the average speed of the aircraft if the journey takes 20 hours. Now we need to know the total distance covered. Total distance covered is the addition of the two distances, that is from P to T and from T to K, and that gives us 39,453.35 plus 6,702.93. The distance will give us 3,945.35 plus 6,702.93, and that gives us 10,648.28 kilometer. That's our total distance covered. Recall, the average speed is given by total distance over total time taken, and that will give total distance 10,648.28 divided by total time taken, which is 20 hours, and that gives us an average of 532.4 kilometers per hour. So that's our average speed. That is the end of question number 1. I hope it is clear. Now let's have a look at another question for further clarification. Example 2. We have 3 places on the earth's surface, point P, Q, and R. They are defined by their latitude and longitude. Point P is 60 degree north, 15 degree east. Point Q is 60 degree north, 48 degree west, and point R is 38 degree south, 48 degree west. Calculate to 3SF the distance PQ measured along the latitude, 2 the distance QR measured along the meridian, and 3 the time taken by the aircraft to cover the distance PQ and QR at an average speed of 800 km per hour. Pi equals 3.142, and the radius of the earth is given as 6,400 km. Solution. We first of all sketch a diagram showing the points P, Q, and R on the globe using the given latitude and longitude. The diagram is as shown. From the diagram, we want to calculate the distance between PQ measured along the latitude. Distance PQ is like the length of an arc on the parallel of latitude 60 degree north. So that is given as theta over 360 times 2 pi r, where theta is the angular difference. Since Q and P are in different poles, Q in the west and P in the east, then we are going to add their angles of longitudes together, and that gives us 48 degree plus 15 degree to give us 63 degree. Hence, distance PQ is given as 63 over 360 times 2 times 3.142 times 6400 equals 60 degree. 60 degree being the angle of the latitude on which we have Q and P. So we have, by calculation, the distance to be equal to 3,519 kilometers, approximately 3,520 kilometers to 3 significant figure. That is the first question. Question 2 says we should calculate the distance QR measured along the meridian. For distance QR, we need to get the angular difference too. And the angular difference will give us the addition of the latitudes, because the two of them are on the same longitude, and that will give us the addition of the latitude will give us 60 plus 38 degree to give us 98 degree. Hence, distance QR is given as 98 over 360 times 2 times 3.142 times 6,400, and that gives 10,948 kilometers, approximately 10,900 kilometers to 3 significant figure. That answers question number 2, which is distance QR measured along the meridian. The last question, the time taken by the aircraft to cover the distance PQ and QR at an average speed of 800 km per hour. In this case, we need to calculate the total distance covered. Then we need to also use a formula that relates velocity, time and distance together. So our total distance covered or traveled is given as the sum of the two distances, which is 3,519 plus 10,948, and that gives us 14,467 kilometers. Recall that our velocity is equal to distance over time. From there we can see that our time taken will be equal to distance over velocity, and that gives 14,467 divided by 800, and that gives us 18.08 hours, which is 18.1 hours to 3 significant figure. I hope these examples are clear enough to give us further understanding of the topic latitude and longitude. Inshallah, the next class we are going to equally have further examples on the discussion. I hope you enjoy the class. Wassalamu alaikum wa rahmatullahi ta'ala wa barakatuh.